Hello and welcome. On the bench today I have an ONKYO receiver. It's a TX-SR806. Apparently it's faulty, so we're gonna see if we can fix it. This receiver is old, but it's not too old. It can still decode lossless codecs like DTSMA and Dolby Through HD, so it's still very usable nowadays. And it's my understanding that this is not suffering the DSP or HDMI chip problem where the sound completely disappears. I made another video on that subject. Those are more or less unrepairable because there's no spare ICs available. So this should be a complete different fault, which I'm not sure about. We're gonna take a look together in a second. Now, because I really don't know much about what's wrong with this machine, and I don't know this machine at all, let me thank today's sponsor, Bullies. And let's start looking into this and let's test it. Alright, let's power this up. Mains is in, and let's turn it on. Okay, it's coming up. Okay, I can already hear some hum. I'm gonna play some royalty-free music. Oh, things have got worse, like with no reason. Things have got suddenly worse. I was about to say that I'm gonna play some royalty-free music so we can test this thing. So let me play this now. Ooh. Alright, so this is very horrible. Let me see, I mean, this could be many things. There is a pure audio button here, which should disable most of the DSPs and stuff. So let's see what happens. What happened to my input? Oh. Why is it going back to DVD? I was on Game TV. Why is it going back? There's something wrong with this. I want to be on Game TV without the pure audio. Ah, that's it. Now it's working a bit better. Right, the amplifier is currently outputting quite a lot of hum, 50 Hz hum. I'm in the UK, so we are on 50 Hz. What I can tell from this is that the amplifiers are probably working, because in pure audio, I don't hear any problem whatsoever. While with the, let's say the DSP, well, digital effects in the way, we might have some noise, which eventually got better. So this could be something that we might be able to diagnose with hot air and cold spray. I would say, let's open it up. Alright, we're in, and there is a layer of dust everywhere. So first thing first, let me use my air compressor, I'll get rid of the dust, and I'll be back on the bench. Alright, this is so much better, and it's also the next day. I've been doing some poking around, and I think I got bad news, but also maybe some good news. Let me show you. So the receiver has been off overnight, and I want to turn it on and show you what happens. Music is coming to the receiver and the speaker is still connected. Now when I turn this on, you'll see that you have the pictogram of the speakers, and it clicks twice. And now we have the buzzing noise. I'm on Game TV, which is the input I'm using, but there are no left and right speakers being highlighted. And that usually is the DSP issue. This is just using a different pictogram, so I wasn't expecting to see the pictogram at all. But this is the DSP fault behavior that we've explored on a previous video. There's something wrong, the DSP is not starting, is something wrong with it internally. And that's it, basically the CPU doesn't get the DSP ready signal, and it refuses to enable the outputs. Now in a minute or so, will take some time. There we go. We have left and right, and well, we get more or less garbage out of the speakers. Now, I don't know whether if I enable pure audio, anything changes. Let's try. it does, and it sounds fine. Now, what happens after a while is that eventually the sound completely disappears and it gets like quieter and quieter until eventually you get just a very little amount of sound out of the speaker with like volume set to stupid levels, and pressing the pure audio doesn't even change that. I can warm up the DSP chips and that will happen more or less instantly. These are the DSPs I'm going to warm up. This receiver, for whatever reason, has two DSPs. I guess technology eventually managed to get one DSP for these units. On these units, you have first and second DSPs. So these two ones, I'm going to warm them up and see what happens. There we go. Actually, the sound has got better this time, immediately, as soon as hot air reached the DSP. Now let me turn this off again and let me cool down the area of the DSP. So basically, to reset the situation, go back to this has been sitting here for a few hours. Okay, everything is nice and cold. Let's turn it on again. We got the two clicks, we got the hum out of the speaker, but once again, there's no left and right labels on the diagram here in front of the front panel. And once again, it should take a minute or so for that area to warm up, and we might get some sound out of it. From my little experience yesterday when I was testing, it changes every time. It keeps changing, and eventually you end up with no sound at all, or that very, very faint sound coming out of the speaker, even at maximum volume. There we go, that's exactly as it was happening before. Let's warm it up again real quick. And right, this is a bit different than what I had before, but more or less it's telling me this is an issue with the DSP. Once again, I'm cooling them down and they don't work. I'm warming them up and they work better. In this case, they work fine. Yesterday, they weren't working even when I was warming them up. There might be some multiple faults on this receiver. I'm not entirely sure that this humming noise I'm getting from the output is the DSP. There might be some faulty capacitors, probably more than one on this receiver. The bad news is that if you watch the previous video, those chips are unobtainable. Absolutely unobtainable. There is no point in ordering anything from AliExpress. They're all fake, they're all rebadged, they're all faulty or whatever. Really, it's a waste of time. So I was about to say, look, I can't possibly think of rebowling, reflowing. It's a short-term solution. That being said, and here comes, I would say, the good news. Now, this is the official ONKYO bulletin about those faulty DSPs that they tend to die prematurely. And there are many pages of models, and there is the affected device and the replacement device. This is the TMS 320D7, and here on the list there is a TMS model. It's the TMS 320C7, which has been replaced with another C7, but with the different rest of the name of the chip. But there's no TMS 320D7 on the list. So I can't be sure that this is the only bulletin available, but it's pretty comprehensive. Again, you got pages and pages and pages of chips. So the first little kind of green flag that I have in my mind is that are those chips actually not subject to early failure? Now, chips can fail. I'm just wondering whether this is not a DSP issue. Coming next, how did I end up doing this? As you can imagine, I spend quite some time sitting in front of my computer editing videos. Sitting down is not healthy, and sitting down incorrectly is even worse. My computer chair has a slippery seat, and whenever I try to sit properly, I slowly but surely slide forward in a less than optimal posture, which then results in backache and neckache. So when Bullies offered to send one of their ergonomic chairs, I could not resist. It was a big box, but the assembly was simple, and in a few minutes the Master Rex chair was fully assembled and ready to be used. It's made a huge difference compared to my previous chair. The water-repellent fabric seat is not slippery and allows me to keep a correct posture when sitting. The backrest is keeping my spine where it should be, and sitting down now feels very comfortable. The armrests can be adjusted in many directions. There is a lumbar support that can be tuned, and setting the height and the recline is just a lever away. And it's great for office use, thanks to its dark color palette. If you want to treat yourself, a convenient footrest slides out, and you can rock the chair for extra comfort. Though the mechanism is a bit stiff, and it's not really designed for those who like rocking back and forth, if this is what you're looking for. All in all, a massive improvement on my previous office chair. Thank you, Bullies, for making my editing time much more healthy and enjoyable. Take a look at bullies.com for an extensive product range, including gaming chairs, office chairs, and standing desks, which are more and more important nowadays for your health. An affiliated link is down below in the description. And the old chair? Oh well. Now, back to our ONKYO. So I started poking around, focusing on this board, of course. This is the HDMI board, and I was looking at the basics. So we have schematics for this receiver, and I see that there is a cable here which is labeled ground and plus 12. And you can clearly see that there is some power management in here, and it's this section here where it says power supply part. Basically you got two plus 12 volts coming in, and there are a number of voltages generated here. You got, this is not being used, but we have 12 volts going through a regulator and some passive components. This is generating plus 1.8 volt core. Then we have another section which is generating plus 2.4 volts DSP and plus 2.4 volts for something else. There are plenty of identical rails on this board, and I guess it's a sound and video device. So you want to keep the rails as independent as possible. And most importantly, you have 12 volts going through another regulator, which is generating plus 4 volts. And on the next page, you see that this 4 volts is being used to generate other voltages, like in this case, 4 volts is going through a 3.3 volts regulator, and it's generating not one, but 1, 2, 3, 4, 5, 6 different 3.3 volts. Each one is going through its own little inductor. I guess it's to keep the noise for that particular circuit within that particular circuit. So for example, noise from a RAM module is not coming back and ending up in your sound system. We have another 4 volts here going into a 1.8 volt regulator. It's called 1.8 volt ADC. That's probably for the analog to digital converters. And here in the corner, I don't know, again, this is ONKYO things. It's on a different page, in the middle of the page. I don't understand. But anyways, we got 4 volts coming in, going through a 3.3 volts regulator as an input. And as an output, we got 3.3 volt DSP. And if I'm going back to where the DSPs are, we got 3.3 volts DSP and 2.4 volt DSP, which we saw was being generated from the same 4 volts, but on a different circuit. And it's going into our DSP. This is the second DSP. There's another page with the first DSP, but it's basically identical. Second DSP, and here on the right hand side, so that's the DSP, we have RAM, 64 megabit SD RAM, and here we got 8 megabit flash memory. So I guess that's the firmware for the DSP. Remember the DSP chip, at least I'm not entirely sure about that one. It should be an ARM processor, and I don't see a serial console on this unit, on this board, so I'm not sure we can actually see what happens. But basically you got 3.3 volts and 2.4, which are powering the both DSPs, number 1 and number 2. The RAM, each one, I think each DSP module has a different DRAM module, and the flash memory, I'm not entirely sure where that is, but it's somewhere. And also I see here in the corner that the 2.4 volts DSP is going through a regulator once again, and it's used to generate 1.26 volts, which I believe it's required. Yes, it's going into the DSP. So the DSP is working with 3.3 and 1.26. The 2.4 volts, I don't think is going anywhere directly. So there is this 2.4 volts DSP, which is only used closer to the DSP to generate something probably very, very clean for the DSP itself. It's probably one is for the core of the DSP and one is for the I/O. I guess the 3.3 volts is probably the I/O. So let's power up the receiver and let's start poking around and see if we can find all those voltages. So this is the main wire where 12 volts is coming in, as we saw on the schematic. So do we get 12 volts here? We get 14.53. I'm assuming that's not really critical, though we might want to double check that one. We have 3 big inductors here, though I think these are through holes, so I can't really access from there. Maybe these little vias here. What voltages am I getting here? I got 1.8, which is one of the voltages. We got 1.8 V core, and then there should be a 2.4 for the DSP. There we go, 2.5. I wouldn't expect this kind of inaccuracy for a DSP, but again, schematics can be mistaken, by the way, and these are ONKYO schematics. But I'm looking for the 4 volts. There should be a 4 volts as well in here. It's probably here. There we go, 3.966 volts. Obviously, there are components at the back as well. I haven't checked yet, so chances are we're missing something. Well, we will definitely be missing something. I got 1, 2, 3 ICs. They look like transistors, but I have a feeling these are voltage regulators. And yes, I got 4 volts coming in on this one, and we are getting 3.3 volts out. So this is one of those which is generating one of the many 3.3 volts. What are we getting here? We're getting, once again, 4 volts coming in, and what do we get as an output? We got 1.8, so that's the whatever. I'm not going back to the schematics, but we saw that 4 volts was being used to generate lots of different voltages. Then we have this one here, which is close to our DSPs, and we have 3.9 volts. So that's again the 4 volts coming in, and as an output, well, we get 2.3. Now, remember there was a 2.4 volts coming to the DSP, though I think it wasn't being used directly. 2.4 volts was actually somewhere here. Yeah, 2.5. Why does this have a 4 volts input and 2.4 output? Let me check on the schematics. Now, that's Q8902, and if I'm going back to the schematics, that is the one getting 4 volts in and generating 3.3 volts DSP for the DSP. It's not supposed to be generating 2.5 volts. Now, these two large-ish inductors close to the DSP, they're actually on the schematics. Basically, they should be carrying 3.3 volts for the DSP, but I'm reading 3.35, which is the same voltage coming out of this regulator. So what's going on here? Let's see what happens when we monitor that voltage when it's powering up, when the unit is powering up. So let me turn this off, and I'm going back to my regulator, which is, again, it's eventually going to those little inductors close to the DSPs. So let me turn it on and see what happens. 3, 2, 1, go. Look, 3.3, 2.3. But it was at 3.3 for a moment. Let's turn it off again. You see, it goes to 3.3 for a moment. To me, it sounds like there's something with that rail. It's supposed to be 3.3, but for whatever reason, it doesn't go to 3.3. I'm just wondering whether the DSP with that lower voltage, maybe that's the cause of our problem. Let me try this again. 3, 2, 1, go. 3.3, and then 2.3. 2.3, 2.4. There we go. Yeah, it stays on 2.3. Let's try and cool down this area. This has been on for a little while I was recording. So let me cool down this area and see whether we are getting anything different. 3, 2, 1, go. We go 3.3, 2.45, 3, okay, it's jumping. 2.43, and again it's jumping. And now again 3 is jumping between 2.4 and probably 3.3. It's probably my multimeter is not fast enough. Shall we take a look with the oscilloscope? I think it's going to be fun to see. Okay, I got the oscilloscope running. It's in roll mode, so you'll see things running from right to left pretty slowly, so we should be able to see what happens. 3, 2, 1, go. Oh, look at that. It goes to 3.3 volts, and then it starts... What is that? I don't know, let's zoom in a little bit and see what happens. Right, that is what's coming out of the 2.4 volts, 3.3 volts regulator, which is a linear voltage regulator. So what is that? Let me try this again. So obviously this is in RMS, it's 2.4 volts, but this is in between, I don't know, it's just jumping all over the place. So let me turn this off again. And it went back to 3.3 for a moment when, you noticed when the moment I switched that off. So let me turn this on again. 3, 2, 1, go. Yeah, it stays at 3.3 for like a second. And then it does that. Now, one option is that there is a short somewhere. It could be like a partial short. And what you've seen on the oscilloscope is the voltage regulator, which has, I believe, on the datasheet, it says it's got overcurrent protection. It's basically trying to provide a current, provide a voltage. It senses an overcurrent, and it kinds of shuts down, but not to 0 volts, and it keeps hicking up. But if that happens, I would say probably the voltage regulator is supposed to be scorching hot. And I have my new thermal camera here, which is a ThermalMaster P3. I really love this thing. These are the DSPs. One is warmer than the other, fair enough. But my regulator is this. So you see something really hot in here. We'll take a look in a minute. It's 50 degrees without doing much. So that's not great. That's the video chips. The video chip is always scorching hot. But our 3.3 volts regulator is not really doing much. Let me get closer. One advantage of this camera is I can get really, really close to the components. And that's my regulator, the one we were testing a moment ago. It's reading 34 degrees. It doesn't look like it's in distress. Let's put it that way. Now, we can definitely take a look at this little one here. It says 50 degrees. It's a very small component. I can see the traces getting really warm, and maybe that's intentional, maybe not. We can take a look straight away. Now, that little IC should be the Q8802, which is getting, once again, 4 volts in, and is supposed to generate 1.8 volt EN enabled. So this is going somewhere here. Well, it's going to the video encoder, so chances are this has nothing to do with our problem, but we can check. We are supposed to see 4 volts in and 1.8 out. Now, it's difficult for me to show you, but I'm probing the input of the chip. I'm getting the usual 4 volts, which is going everywhere on this board. And what are we getting as an output? Okay, well, it's not 1.8. Is that just schematics inaccuracy? I don't know. Let me see what happens if I turn it off and on. Does this jump to 1.8 and then goes back to 1.5? 3, 2, 1, go. Yes, that's another one. This is another one that goes to 1.8. And then it goes down to 1.5. This feels like a power supply issue with this receiver. It doesn't feel anymore as the usual DSP problem. It could be, but this line is not supposed to be 2. Oh, it's 3.3 now. Look, we definitely have a problem with the 3.3 volts regulation. Now it's 3.3 and it's stable at 3.3. Look, perfectly stable at 3.3 volts. And what about the 1.5, 1.8? Oh, look at that. I mean, it's in bad shape. Now, the 3.3 volts regulator, which is generating 3.3 volts DSP, is the BA33BC0FP. And according to the datasheet, this is just, it could be a variable output regulator, but the BAXXBC0 is the fixed version. The variable would be this name in here. So the 3.3 in the name tells me it's a fixed 3.3 volts regulator. This can only output 1 amp, which is expected from a linear voltage regulator. And as I said, these features an overcurrent protection circuit. Overcurrent protection is incorporated in order to prevent destruction due to short-term overload currents. As any linear voltage regulator, a capacitor on the output is required to prevent oscillations. Just wondering whether maybe the capacitors are completely dead and the chip is just oscillating. And that's what we are seeing. We are actually seeing it's oscillating. It's not stuck at 2.4 volts. It's going up and down. So maybe that's it. I think there is a 100 volt capacitor. I think is on the schematics. Yes, there is a 100 volts, 4 volts on the output. Now, the smaller regulator, which we saw on the thermal camera, was running at 50 degrees, is the Q8802, and that's the product number. And the datasheet says it's a high-speed LDO regulator, low ESR cap compatible, ultra small package. And if I'm going down a bit, basically these two numbers in the product naming is the output voltage. So because on the datasheet it says 1.8 here, that would be the output voltage. So that should be a fixed voltage regulator. It's not supposed to read 1.5 volts. So I would say, shall we take this board out and let's find these capacitors which are on the output line. Let's remove the board and let's start taking a look at that. Oh wow. The card is out, and actually I can see here at the back Samsung modules, which are basically directly behind the DSPs. So these are the RAM modules, and I guess these are the firmware module, the flash RAM, flash ROM modules. And also I see these two ICs here. One is the Q7302 and one is Q7202. These are the ones creating the 1.24 volts or whatever. Now, if I'm going back to the schematics where I had that very small regulator which was supposed to generate 1.8 volts but actually was doing 1.5, the capacitor, which is basically there to prevent oscillation, that would be C8824, and it turns out to be this one here. It's a 100 microfarad, 4 volts, while the other regulator, which is the one supposed to generate the 3.3 volts DSP, which I feel is the one which is directly affecting us, that would be the C8919, and it's this little one here, C8919. It's another 100 microfarad 4 volts. So we can check those two, and I'm used to dealing with SMD capacitors. I'm using two ions to remove them. It really takes a second. Let's remove both of them, I would say, and let's double check that these are actually good capacitors, because if that's not good, that's our problem. So I'm not going to use any plier method or anything, because everybody's doing it the way they want. I'm going to add a little bit of flux, and then I'm going to add a little bit of leaded solder to lower the melting temperature, because this board is not preheated. Then maybe some extra flux. And then I'm just removing, I should be able to remove the capacitor pretty easily. There we go. Okay, well, unless I'm making bad contact, this capacitor is completely gone. I've got 6 microfarad and 1.1 kilo ohm of ESR. Let me get a 100 microfarad capacitor. Now, I don't have this very low voltage in SMD. I probably have bigger ones, which is fine, but it probably won't fit. Now, this is what I've got. I think they're like 25 volts or something like that. There we go, 93 microfarad and less than 1 ohm of ESR. And right, I don't have any SMD capacitor this size. Everything is slightly bigger. So I'm going to go with through hole, which is totally fine. Yeah, to me, it actually works pretty well. These are Panasonic 16 volts FR series. These are very low ESR. And this is even reading 85, so kind of a low side, but I got 300 milliohms. You need something in between 0.075 ohms and 1 ohm. This is 300 milliohm, so that is actually in the middle of the stable region. Let's install this one, and then we'll go and check the other one. And this is also gone. It's only 30 microfarad, 50 ohms of ESR. So yeah, this is well over the unstable area of those regulators. Three, two, one, go. We go 3.3. Never had 3.3 volts for more than a couple of seconds. What happens to that 1.8 volts line? 1.8. Wow, that's super interesting. That is super interesting. I was aware that linear voltage regulators needed some capacitance afterwards, but I had never seen a linear voltage regulator oscillate. Let me wire everything back up, and I'll show you the front panel with my other camera, and we'll test it. Is this gonna work? Let's turn it on. What's gonna happen? I'm really curious. 3, 2, 1, go. Okay, are we going to get... Yes, immediately, left and right. And we got sound, even though it's working. But it's still humming in the background. It is working, so it wasn't a DSP problem. It was a problem with the DSP supply. Now, there is still a pretty loud hum in the background. Alright, let's try to find out where this noise is coming from. Now, the first thing I'd like to find out is, does the noise follow the volume control? Because that would tell me that the noise is coming before the volume control on the circuit. Well, it does and it doesn't. It definitely gets louder at some point, but below a certain value, it doesn't really change much. So it looks like there is a baseline noise coming from after the volume control, but there also is some noise coming from before the volume control, which gets amplified by the volume control itself. The second test would be, does the noise go away when I mute the amplifier? And yes, there is an effect, though the noise doesn't go away 100%. And this is also confirmed by the fact that when I'm changing the input, the noise for a few seconds, I don't want to say it goes away, but it reduces considerably. It's basically the same reduction as when I'm muting the inputs. Let me show you. So this once again is telling me maybe that the noise is coming from before the amplifier. When I'm saying the amplifier, is that the bottom board on this receiver, or I would say on any ONKYO receiver, is the amplifier board. It actually has channel inputs on that board, and I think it's more or less completely separated from anything else. I could feed something else at that board. Now inside the receiver, I think I can see the connector, which is basically the output of the electronics into the amplifier itself. And what I'd like to do next is to turn everything off and unplug that connector. If I'm not mistaken, that should basically remove the inputs from the amplifier board. And at that point, the amplifier board is supposed to be completely silent. So let me turn this off and let me see if I can unplug that connector. And there is no noise whatsoever. It's gone completely. It is completely quiet. So unfortunately, I'd like to say, it looks like the noise is coming from the electronics. The question now is, how do I find out where the noise is coming from? It could be anywhere. This is the connector that is connected to the electronic boards and is basically the input of the amplifier. I disconnected this connector and the noise went away. I want to make sure that there is maybe some sort of other protection or something, and somehow the amplifier is being switched off by the CPU, maybe because it's sensing that this is disconnected. I doubt it. So I wired it to the output of my laptop. Might not be the greatest sound quality, but we don't care at this stage. Okay, turn on the ONKYO, 3, 2, 1, go. Ah, yes, of course. So obviously the volume control is not working because the volume control is before the amplifier. So I'm bypassing everything right now. And this is great news because the music is running. But if I remove the sound from the laptop, there is no noise. There is no 50 or 100 hertz noise. So that is telling me 100% that the amplifier is working, but the amplifier doesn't generate that noise. So the noise is not coming from here, it's coming from here. Now, I was studying the situation to understand what to do next, and I stumbled onto a video where a technician was fixing more or less a similar problem with the DSPs on these not this very unit, but a unit like this, by replacing the very same 100 microfarad capacitors. What if just the 100 microfarad 4 volts capacitors have gone? I think there are about 15. I had a look on the schematics, there were 13, 15, something like that. Let's take the board out and let's start testing those capacitors, because chances are they all failed. Right, the board is out and I marked the 100 microfarad 4 volts capacitors with the red marker. So we go 1, 2, 3, 4, and then at the back we have 5, 6, 7, 8, 9, 10. We have some other 100 microfarad, but they are 16 volts, so they're bigger. But let me remove a few and we'll move from there. Well, this one is reading 22 microfarad and 78 ohm of ESR, so this is definitely gone. Now, I don't know whether that is our problem, but we definitely need to replace probably all the 100 microfarad 4 volts capacitors. And these are also all gone. This one is reading 2.8 and ESR is off the scale. This one is reading 30, but ESR is 37. And this one is reading 6, but the ESR is again 800 ohms, so they're all gone. Let's move to the back of the board and do the others as well. And yes, they're all gone. I will save you testing them one by one, but the best one reads 22 microfarad and very high ESR, and this one is reading only a few nanofarads, and the ESR it's like kilo ohms. So yeah, these are completely gone. So thank you for the technician that published that video that gave me the idea. So this will need to be replaced, and hopefully they are the source of our problem. Now, my next question would be, what about the other capacitors? So maybe I'll just remove a couple of capacitors and just test them just to see if I have a good reading. Maybe I can assume that the rest of the capacitors are good, and if I had a bad reading, well, then it's bad news, I guess. And I guess we have bad news, because this is a 220 microfarad, it's reading 51, and with a very high ESR. This is a 100 microfarad, but this is 16 volts, so that the bigger brothers. It's reading 30 microfarad and a very high ESR. Well, there's no point in continuing testing these caps. I just need to replace them all, unfortunately. So place an order with a proper size, proper everything. And it will take a little bit of time, but I'm used to replacing SMD capacitors, so it's not the end of the world. Let's do it! I have shown my SMD capacitor removal before, so this is nothing new. Swapping the big capacitors was nothing special. The trick is to preheat the board and use a very large tip, at least to remove them, as some of those pads will be connected to ground planes, which will try to wick away all the heat. The large tip will probably melt away some of the plastic base of the capacitors, but who cares, you're going to dispose of them anyway. To fit new capacitors and also replace those through-hole ones I used earlier on, I use leaded solder, some flux and smaller tips, but still large enough to have enough thermal mass. I solder one leg at a time, making sure the capacitor is fully seated. Now, I had kind of a change of mind about the small capacitors, because they're really small. It's going to be not easy to desolder and resolder them. And I thought, you know what, I'm going to remove one and check it out. If it checks okay, maybe we can live with that. Now, I've removed this one and it's reading 17.7. It's a 22 microfarad, so that's not too bad. But the ESR is very high, it's 51. Now, granted, this is a small value, and small value capacitors, they will have a much higher ESR, but this is a brand new Wurth one. I'm not sure if you can see it, it's the red one. They decided to make them red, probably to justify the cost. And besides that, it's reading closer to 22, it's reading 14 ESR, and this is 100 Hz. Now, if I change it to 1K, 1000 Hz, now the existing capacitor is reading more or less half the capacitance, but the ESR is 41 ohm, while the brand new one is still reading good capacitance, but most importantly, an ESR of 6. So no, I'll have to go ahead and do my best and try and replace them all. I'm thinking maybe I could use the microscope, I don't know, let me think about it. The microscope idea was good. In fact, I'll keep using it for completing the larger capacitors later on. I used my small 210 soldering handle with a fine knife tip, though I only have one of those handles, so for the other iron I use 1245 handle, but with a knife tip too. The sharp edge of the knife tip makes it more suitable for small spaces. And that worked perfectly. With the extra control given by the magnification, removing those tiny caps was simple and somehow relaxing. Installing the new ones was also very simple. I didn't damage anything and the outcome was better than factory, as someone would say. By the way, once those small caps were removed, I checked a few more of them, and yes, they were all dead, so a full recap was absolutely necessary. The board is done. I'm gonna wash it with isopropyl alcohol to make sure it's nice and shiny so that I can compare it with some high definition pictures I took before working on the board, and I'm going to check that all the capacitors are the proper orientation, voltage and capacitance. And all the capacitors on the board are properly installed, but I forgot a few. These 322 microfarad are not on the board, and these two 100 microfarad are not on the board. So let me put them on, and then the board is done. Everything checks out, time to reinstall the inductors. As a quick sanity check, I'd like to make sure there are no shorts on the main rails. So I'm checking between ground, which is the tab of this component, and the output. In this case, probably one of the many 3.3 volts. There is no short. The input is the 5 volts, which is powering many of those. They're all connected together, and there is no short. So I can check all the others as well. And I don't have shorts on any of these regulators. And here at the back I have more regulators, which I've checked already. I have these ones without checking on the schematics. I got the tab, which is ground, and then I'm checking on all the legs. And I have no shorts, only this one is reading 100 ohms, which is not short, and is reading 100 ohms on both of these components, and the other leg is not reading anything. Just as a final check, let's get the main input, which is the 12 volts here at this connector here, and let's make sure that we haven't got a short here. And we don't have a short here. So I'm reasonably confident that this is not going to go up in smoke, but we will know in a second. Right, little setback in here. I was reinstalling the board and I realized that the screw of the HDMI ports, they don't line up anymore, and I could feel something in the way. And it's one of my capacitors. Well, I didn't really think too much about the height of the capacitors because I thought there's plenty of height. I don't need to get worried about that. But obviously I didn't think about this one. So I guess for now I'll just put some plastic in between, just for a test. But I'll have to find a shorter one. Time to test it. Will it work? Will it go up in smoke? And most importantly, will the buzzing noise have gone? Giving mains to the unit. 3, 2, 1, go. And let's turn it on. 3, 2, 1, go. Oh no. It's even worse. Well, the good news, it's working, and that board definitely needed to be recapped, 100%. There was no single capacitor which was in good shape, so that had to be done. But the buzzing noise is still there. And it was really loud at the beginning because I didn't realize the ONKYO restarted from my previous volume, which was very loud. But no, it's basically unchanged, so it is something else. I will require a little extra diagnostic to find out where the buzzing noise is coming from. So this video is getting a bit long. I'm gonna pause it now, and there will be a part 2 where I will go back to the drawing boards and see if I can find where the buzzing noise is coming from. But so far I'm really happy. We found where that noise was coming from, not the buzzing noise, the digital noise, let's call it that way. We actually identified the wrong component without just starting replacing components randomly, and we ended up recapping this whole board, which wasn't a waste of time because every single capacitor I tested from this board was either completely dead or about to die. So the board 100% needed a recap. And I'm mildly optimistic that in part 2 I will be able to find where the buzzing noise is coming from, and hopefully to get this processor, get this receiver to a point where it's working flawlessly. I will put a link to part 2 down below in the description as soon as it's ready. Meanwhile, if you enjoyed this video, I would really appreciate a thumb up down below, and consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and Patreon, and the links are also down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, well, I hope you enjoyed this video. That's it for today. Thank you so much for watching. I hope you have a great day, and I hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.